All right, so this will be our second to last lesson of chapter 9, and well, like I told you guys before, we'll probably stay with that slower pace. So I'll give you a chance to work on this tomorrow in class, ask questions, etc. And so this is about arithmetic series. Okay, our first lesson was about arithmetic sequences. Anyways, our learning target is I can find the summation of an arithmetic series and understand summation notation. So the definition of a series says a series is a number of objects that happen in order or one after another. So basically, when we think about a series in math, we're thinking about adding up a series of numbers. Okay, so like an example here, if that's the sequence, then we can get the sum by adding all of those numbers together. All right, so the summation of this sequence would be 60. All right, so we're going to look at kind of some different things that happen when we go to try to find such summations. All right, so like example 1, what if I asked you to find the sum of the first 100 positive integers, right? So that would be like you'd take 1 plus 2 plus 3, right? And you'd have to keep going on and on and on and on, right? So that would take a while. Okay, you could do it. You could punch them all in, but you'd probably make a keystroke error somewhere along the line, and it's just really not practical to ask you to do that. Yes? Yeah. If you need to, go ahead and sign out. So, anyways, we're going to look at how could we do that in a more practical way. All right. So, with all 4 of our lessons, you're going to have one kind of big takeaway as far as a formula. Okay, so you can look back at our first 2 notes. There's a key formula today. This is our key formula. S sub n equals n over 2 times the quantity a sub 1 plus a sub n. So defining our terms, S sub n just means the sum of the n terms in the series. We know what a sub 1 is. That's the first term. A sub n is the last term. Okay, and then n is the number of terms in the series. Okay, so let's go ahead and do the easiest example first, which is A, where they give us everything we need. All right, so again, I'm looking at that formula I just highlighted, and I'm going to plug in the values that they give me. So if n equals 8, then we're finding S sub 8, the sum of the first 8 of this series. All right, and that's going to be n over 2, so that's 8 over 2, times the quantity a sub 1 plus a sub n, and they give us those directly. So a sub 1 is 7, a sub n is 79. So then we just go ahead and use our calculator from there. If you wanted to simplify that down, that's just 4 times 86, but you could type it in just like you see it. Why don't you go ahead and do that, and just make sure that you're seeing that it's 344 is what you should see. All right, anybody got any questions on just that? That's a really simple example. That would be easier than like what you might see on a test. So B, C, and D kind of have some trickier stuff going on with them, right? So let's go ahead and let's do C, and then let's see what you guys can do on the other 2 we skipped. Okay, and let's see why it's trickier. So anyways, well, now that we know how to do this, actually, let me follow up with this. If we wanted to be able to do this now, here's what we would do. Okay, we would say S sub 100 is equal to 100 over 2 times the quantity 1 plus 100, right? And then that would be a lot easier to type in than 1 plus 2 plus 3 plus 4 plus 5. on and on and on, right? So that's going to be 50 times 101, which gives me 5,050. Okay, so that's what the shortcut does for us. Lets us do that summation in a practical way. All right, anyways, let's go ahead and do C. Okay, so we need to know what n is. That's what we don't know. But looking at the series for C, what's a sub 1? What am I going to use for a sub 1? 14. What about a sub n? What's that going to be? That's going to be 116. So a sub n is just our last one of the sequence, whatever that is. So a sub n is 116. And then what we don't know is what's n. Okay, so we could fill in the blanks, like obviously we're counting by 3, then we have 23, 26, 29, right? But that'd be a lot of counting, a lot of filling in, right? So we want to find n algebraically, right? So we don't know n, bless you. So how can we find n? Okay, so we think back to our arithmetic sequence kind of formula. Our key formula there is a sub n equals a sub 1 plus the quantity n minus 1 times d. So we're going to use that to find n. So what's my common difference in this series? What am I counting by? 3, right? So we have to see that d equals 3. And now we'll kind of just sub in, all right? So we could set this up as 116, bless you, equals a sub 1, which is 14, plus we don't know n, so n minus 1 times d is 3. And now we'll solve that for n. So that gives me 116 equals, I'm going to go ahead and distribute and combine like terms in one step. So 3 times n gives me 3n. And then I'd have negative 3 plus 14, so that gives me plus 11. So that's a shortcut to figuring out that we have 35 terms in that series. That's what we had to figure out. That was our missing piece. Now that we have that, now we just plug in, okay? So now we know we're finding S sub 35. So 35 over 2 times the quantity a sub 1 plus a sub n, so 14 plus 116. Let your calculator do the work for you. That's going to give you 2275, 2,275. All right, so let me give you guys a few minutes to try B and D. I encourage you to work with each other. You're missing some information in both of them. D is just like C, so that might be a good place to start. But for whatever you're missing on example B, you could use this formula right here. Okay, just try your best. Do what you can do. Obviously, we'll talk about both of them. Let me give you maybe 3 minutes instead of 2 minutes. Get as far as you can on C and on D. And then we'll talk about it. And I didn't see that listed, but your arithmetic sequence formula is listed right there as well. All right, so let's start by looking at D. D was just like C, so I think it would have been smart to start there. Can I get a volunteer to tell me what the final answer is, and then I'll kind of take you through it. Caroline, what'd you get? So 23 is a missing piece, but that's not the final answer. But 23 is a needed piece. That's all right. No, that's good. You're heading in the right direction. Ernst? Negative 46. Very good. So here's how we get it, right? So we do need that missing piece to know that we're finding S sub 23. All right. That means there are 23 terms. Once we have that, it's pretty easy. Just 23 over 2 times the quantity 20 plus negative 24. That's going to give you your negative 46. The key is, though, how do we come up with the 23 part? All right. So does anybody need to see that? How we come up with 23 terms? Are you guys good to go on that? All right. So yeah, you might want to remind yourself we had to find n equals 23. All right. Next one is a little bit different. Well, I guess it is kind of the same as these other two. So anybody want to take a shot at what our final answer is on the last one, Shrieker? On B. I'm sorry. On B. Yes. It is 495. Very good. Very good. So I apologize. It is not the same, right? What we had to find there was A sub 1. Right? That was the key missing piece, and once we do, then we can get it. You guys need to see that, how we find A sub 1? Yeah. All right, let's look at that. All right. So all going to be based on this, right? So taking what we have to find a missing variable. Okay. So what we have is basically we know the 11th term is 80, right? This is A sub n, or you could say A sub 11, right? Because we know n equals 11. Anyways, now that we know that, then let's plug in. So A sub n is going to be 80 in this case, equals A sub 1, which we're solving for, plus the quantity n minus 1. We already know n here, so 11 minus 1. We also know d is 7, right? So this one ends up being pretty easy to solve for. So take it down a step. That would give me 80 equals A sub 1 plus 10 times 7, which is 70. And then subtract 70 from both sides to get 10 equals A sub 1. That's the missing piece, right? Once we know that, then we can plug in, because we have A sub 1, we have A sub n, and we have n. Those are the three things we need, okay? So then A sub 11 equals 11 over 2 times the quantity, 14 plus 80. And then you just let your calculator do the rest. That's how we get 495. I don't know why I put 14. I'm sorry. It's like looking at a different example. A sub 1 is 10, so let's try 10 plus 80. Sorry about that. All right, and so anyways, that will give you 495. Is everybody with me? Does anybody have any questions about any of those steps or anything? You guys doing all right? Okay, so moving on. To the back side. All right, so now we're going to get into using summation notation. All right, so summation notation kind of looks like this. All right, So that's the Greek letter sigma, that big looking Greek symbol in the middle, and then kind of what everything means. All right. So if n equals 1 or whatever is there, that's going to be my lower limit. Sometimes that's referred to as LL, capital L, capital L. And that's just that just signifies that's the first term or the starting term. Okay, we're starting with the first term in this case. Usually it says n equals 1 at the bottom. Okay, it doesn't always have to, but usually you start with the first term, and then that's my upper limit. Sometimes referred to as capital U, capital L. All right, so this would tell me then what this literally means. I don't know if you want to write this down or not, but this literally means we're finding the sum of the first term to the 10th term, and then this is the rule of the series, right? So the first term would be 1 times 3, or 3 times 1. So you'd have 3 plus the next term would be 2 times 3 would be 6. Plus, and then we go all the way to the 10th term, which would be 3 times 10. So the last one would be 30. So that is, this right here is what is meant by, what we see over in the diagram. Okay, does that kind of make sense to everybody a little bit? No response. Maybe that means no, but we'll try to use it a little bit and see if we can figure it out. Okay. All right, so let's just jump in. They give you a strategy over here, but we'll just go ahead and work through it. So we need to figure out, to ultimately use our formula, we need to know what's a sub 1. All right, so a sub 1 on this one is going to be, basically you just plug in 1 for n, okay? So it's just going to be 3 times 1 minus 8. -5. All right. We also need a sub 40, because that's my upper limit. I'll call that a sub n. And so that's going to be 3 times 40 minus 8, which is, make sure I don't mess this up, 112. All right, and then we know n equals 40. All right, so then we're ready to go ahead and sub in. Any questions before we go ahead and use the formula? Everybody see what I did so far? All right, so we're finding s sub 40. So 40 over 2 times the quantity of a sub 1, which is -5, plus a sub n, which is 112. So we're taking, looks like 20 times 107. And that's going to give me 2140, 2,140. Any questions before we keep moving? You guys with me? All right. Let's skip B, and I'm going to leave that one for you guys. Maybe do one more together. C is a little bit weird. Like I said, 9 times out of 10, this is going to be n equals 1. But, it's fine. We're just finding the 4th term, okay, in this case. But I would still say, just for, to have some continuity, we'll still call the 4th term, in this case, a sub 1, which is kind of weird, but we'll just do that for this one. So we'll say a sub 1 here equals -2 times 4, so -8. And then a sub n equals -2 times 12. So -24. All right, and then we need to figure out what n is. So a lot of times, you know, n is just the top number, okay? But if we're starting at the fourth term, n is not your top number here, right? So how many, can anybody tell me how many terms are in this series? If we're starting at the fourth term and then at the 12th term, how many would that be? Everybody wants to say 8, right? But that's wrong, okay? You got to be careful. So it's actually 8 plus 1, okay? Because when we do the difference of 12 and 4, which is the right way to think, we miss that first one, okay? So, you know, think about if I said how many numbers are there from 1 to 9, you'd say 9. But if we take 9 minus 1, that's 8, right? So you do the difference plus 1, okay? So n here equals, just pointing out to be careful there, n equals 9. You might want to note that we did 12 minus 4 plus 1. Bless you. All right, so now we have everything we need. We just go ahead and plug in. So we're finding s sub 9 is 9 over 2 times the quantity, negative 8 plus negative 24. I'll just put negative 8 minus 24. And that ends up being negative 144. Negative 144. All right, so I want you guys, well, any questions before you go? All right, so you guys do B. So the summation of the first 50 terms of the series described by the rule 4n plus 7. All right, I'm going to pick on somebody here. So let's see, Aiden, were you able to come up with it? It's not 4260. That's all right, though. Delaney, what'd you come up with? All right, it is 5450. And if you didn't get that, here is how here's how we get it real quick. So we need, a sub 1 is just going to be 4 times 1 plus 7. All right, so that is 11. A sub n or a sub 50, you could call it either way, is 4 times 50 plus 7. So that's going to be 207. And then n equals 50. Once you have that, then you just plug in, okay? So we say s sub 50 equals 50 over 2. And again, so think about it's obvious when we go from first term to 50th term that there are 50, but again, think about that. If we did 50 minus 1 there, we get 49, right? So when you're counting them, just remember to add 1 in. So anyways, 50 over 2 times the quantity, 11 plus 207. And that's going to be 5450, 5,450, okay? Any questions after I showed that? All right, so there's one more type of example, which is not going to leave you really any time to work, which is fine because I'm going to give you some time tomorrow. So take a deep breath and we'll finish strong here. Okay. So now I'm going to give you what we're given here is just an actual series itself, like written out longhand, and we're going to rewrite that using summation notation, right? So go ahead and practice your Greek letter here, sigma. So let's go ahead and start with that. All right. So unless it says otherwise, or unless there's like a dot, dot, dot in front of it, we have to assume 5 is the first term, okay? So we'll say n equals 1. 5 is the first term, so that's why n equals 1. How many terms are there listed out? 5, right? You just count them out. There are 5. So we're going from terms 1 to 5. 1 is my lower limit, 5 is my upper limit. And then we have to be able to write the rule, okay? So the rule here might be pretty obvious. Does anybody just see what the rule would be? Like if I told you to write a linear equation to describe that rule, 5, 10, 15, 20. It's not plus 5. We'd say times 5, right? 5 times n, okay? But here's how we can come up with it, all right? We can just use, we can just use our given kind of formula. Think back to, you don't have to flip back, but think back to this, right? So, yeah, we can just, you got to figure out D is 5, obviously. So once I know that, I can use any of these two terms to write my rule. So let's just say we use the first two. So if we say 10 is a sub 2 equals a sub 1 plus n minus 1, so that'd be 2 minus 1. Let's see. I'm telling you wrong here. That would be to find D. So, okay, let's just leave it as, well, I'm going to give you a good way to do this. Okay, so let's just use a sub 1. Yeah, what I was showing you is to find n. I'm sorry. So, yeah, just to find the rule, we'll just use a sub 1 is 5 plus the quantity n minus 1. We'll leave that as the generic n minus 1 times d. So d is 5. And then we just go ahead and simplify that. All right, so distribute, you get 5 plus 5n minus 5. And then we're left with just 5n. Okay, the 5 and the minus 5 cancel each other out. So that's my rule that goes there. All right, so you guys then go ahead and try to repeat that for the last one. Just try your best, and we'll see if we've got it. Okay, let me give you more like a minute 30 on this one. All right, so kind of the gimme part is that we're going to use the sigma symbol. We're starting from the first term. Can I get a volunteer to tell me what goes up there? Yes. What is it? 2. No, 2 doesn't go up there. That's all right, though. What goes up top? Madison? No. That's all right, though. Yes? It's 7, right? So what goes up top is your number of terms, okay? So you may want to note that. So 7 goes up top. And then lastly, what goes there? What's my rule? Anybody think they have that? Sydney? It is 2n minus 4. Very good. Okay. Anybody want to see where we come up with 2n minus 4 or have any other questions? All right. So that's it. Yes? 2n minus 4. All right. So to close, how we get 2n minus 4. Basically, you need 2 things. You need to know what's your common difference. All right. So figure out d equals 2. And what's a sub 1? So given that, then we just plug into our formula. We go a sub 1, which is not negative 21, negative 2, plus the quantity n minus 1 times d, and then we just distribute and combine like terms. Okay, so negative 2 plus 2n minus 2. And then you have, so 2n, and then negative 2 and negative 2 make negative 4. All right. And then we can see it works, right? If we plug in 1, we get out negative 2. If we plug in 3, we get out 2, right? It should work for any term in the sequence. All right, guys. So, yes?
How would you know if the bottom of the term
Uh-huh.
equals 1? How would you know if it's not?
You just assume it's 1, okay, unless they say different, okay? Well, and also just visually, you know, if there's no like if you're just looking at this, there's no dot, dot, dot or anything before the negative 2, that means that the series starts there. So that's the first term. Does that make sense? Yeah. All right, gang, so your homework will post. Like, I'll go ahead and post it, but feel free to hold off till tomorrow. I'm going to give you time in class. I'm going to have one little extra thing for you guys to do at the beginning, but most of the time will be Q&A time, all right? So, virtual kiddos, if y'all don't have any questions for me, you can go ahead and dismiss yourselves. If you do, feel free to stick around.